Hello and welcome back to Steve and Data. Today in this video I want to talk about binomial distribution and its properties like mean and variance. Okay, let's get to it without killing the time. Before jumping into the mean and variance formulas, consider the following examples. Flip a coin 10 times. Let x be the number of heads obtained. A Warn machine tool produces 1% defective parts. Let x be the number of defective parts in the next 25 parts produced. Each sample of air has a 10% chance of containing a particular rare molecule. Let x be the number of air samples that contain the rare molecule in the next 18 samples analyzed. These examples illustrate that a general probability model that includes these experiments as a particular cases would be very useful. Each of these random experiments can be thought of as consisting of a series of repeated random trials. 10 flips of the coin in experiment 1, the production of 25 parts in experiment 2, and so forth. The random variable in each case is a count of the number of trials that meet a specified criterion. The outcome from each trial either meets the criterion that x counts or it does not. Consequently, each trial can be summarized as resulting in either a success or a failure. For example, in a multiple choice experiment, for each question, only the choice that is correct is considered a success. Choosing any of the 3 incorrect choices results in the trial being summarized as a failure. But hold on and pay attention to this point. The terms success and failure are just labels. We can just as well use A and B or 0 and 1. Actually, a trial with only 2 possible outcomes is used so frequently as a building block of a random experiment that is called a Bernoulli trial. It is usually assumed that the trials that constitute the random experiment are independent. This implies that the outcome from one trial has no effect on the outcome to be obtained from any other trials. Furthermore, it is often reasonable to assume that the probability of a success in each trial is constant. In the multiple choice experiment, if the test taker has no knowledge of the material and just guesses at each question, we might assume that the probability of a correct answer is 1/4 for each question. Now, before checking the binomial distribution formula, let's see a simple example. The chance that a bit transmitted through a digital transmission channel is received in error is 0.1. Also assume that the transmission trials are independent. Let x be the number of bits in error in the next 4 bits transmitted. We are interested in the probability of x equals 2. Let the letter E denote a bit in error and let the letter O denote that the bit is okay, that is, received without error. We can represent the outcomes of this experiment as a list of 4 letters that indicate the bits that are in error and those that are okay. For example, the outcome OEOE indicates that the second and fourth bits are in error and the other 2 bits are okay. The corresponding values for x are in this table. And the event x equals 2 consists of 6 outcomes. Using the assumption that the trials are independent, the probability of EEOO is the probability of E times the probability of E times the probability of O times the probability of O, that is 0.1 squared times 0.9 squared, and this is equal to 0.0081. Also, any of the 6 mutually exclusive outcomes for which x equals 2 has the same probability of occurring. Therefore, the probability of x equals 2 is equal to 6 times 0.0081, that is 0.0486. Now let's see what the binomial distribution mass function is. A random experiment consists of n Bernoulli trials such that the trials are independent. Each trial results in only two possible outcomes labeled as success and failure. And finally, the probability of a success in each trial, denoted as P, remains constant. The random variable x that equals the number of trials that result in a success is a binomial random variable with the parameters p that is between 0 and 1 and n. The probability mass function of x is equal to n choose x times p to the power of x times 1 minus p to the power of n minus x. Now again, let's see an example of the binomial distribution probability mass function. Each sample of water has a 10% chance of containing a particular organic pollutant. Assume that the samples are independent with regard to the presence of the pollutant. We are interested in finding the probability that in the next 18 samples, exactly 2 contain pollutant. Let x be the number of samples that contain the pollutant in the next 18 samples analyzed. Then x is a binomial random variable with p equals 0.1 and n equals 18. Therefore, the probability of x equals 2 is 18 choose 2 times 0.1 squared times 0.9 to the power of 16. And that is equal to 0.284. But before wrapping up the video, let's check what the mean and the variance of the binomial distribution is. If x is a binomial random variable with parameters p and n, the expected value of x equals n times p and the variance equals n times p times 1 minus p. Now it's time to wrap up the video by reviewing what we have learned so far. First, we saw that in probability theory and statistics, the binomial distribution is the discrete probability distribution that gives only two possible results in an experiment, either success or failure. Then we saw the probability mass function of binomial distribution, which was equal to n choose x times p to the power of x times 1 minus p to the power of n minus x, and then we understood how to calculate its mean and variance by the formulas below. And that is done. Congratulations! Now you know what the binomial distribution is and you can solve and model real-world problems with the help of it. And remember, for more information about other distributions, you can check out this playlist. Finally, if you like this video, please hit that like button, and if you are interested in statistics, data science, and machine learning, please consider subscribing to this channel. By the way, if you have a question about the fields I mentioned, comment it down in the comment section. And don't forget to share my videos with your interested friends. I hope this video helps you a lot, and until the next video, happy learning!